Hey everybody, this is just one video for this section, but it kind of covers a lot of operations with rationals. Some of this stuff you've probably seen problems like this before, maybe even all the way back in pre-algebra with proportions and things like that, but we're just going to go through what is a rational expression and how do we simplify it, then how do we add, subtract, multiply, and divide with them. So I'm only going to go through a couple examples, but I do have the notes posted more legibly with some pen where it says the video notes complete. So make sure you go through that as well if you feel like you want to go through these notes and try them yourself, and then check and make sure you're on the right track. All right, so a rational expression is a ratio of two polynomial expressions. We kind of went over that in the other videos. So a rational function has polynomials in the numerator and in the denominator. Okay, so we're just talking about expressions here. So we're going to first talk about simplifying. So the very first thing we always want to do, factor everything that we possibly can, and then we want to simplify using any exponent rules or cancel out any common factors. Okay, and then we should be fully simplified. So just going through a couple of examples. Number one, 20 and 14 can both be divided by 2, so I did that to simplify that section. Using exponent rules, we can take x to the 6th divided by x squared. So we're subtracting those exponents for exponent rules, so we get x to the 4th. If you wanted to have the 10x to the 4th all over 7, that's fine too. Okay. Number two, I factored in the numerator. So we had 6 times k minus 6. And then that means that there is a common factor in the numerator and in the denominator. So I canceled that out and we're just left with 6. Number three, if I factor in the denominator, I'm looking for factors of negative 48 that add to give me 2. So I found 8 and negative 6. Okay, and then y plus 8 and y plus 8 are in common on top and bottom. So that means that I should have just 1 over y minus 6. And so this line should be all the way extended. I don't know why it's not, but there we go. So 1 over y minus 6. Okay, and then I left a couple of them blank, but one thing I want you to see, they're saying watch out, a minus b over b minus a, it actually equals negative 1. Okay, so I kind of went through the math here to show you. If I switch the order in the numerator, it would be negative b plus a. Okay, and then if I take out a negative 1, that gives me negative 1 in front of b minus a, right? So then we'd have a common factor. So you want to notice those types of things. So in number 5, when I factor the numerator, I should get p plus 7 times p minus 7. In the denominator, I have 7 minus p. So these are very similar, except for that the order's kind of switched around, and so are the symbols. So I know that that simplifies to give me a negative 1. So I could say negative 1 times p plus 7, and that's fine, or I could say negative p minus 7, either way for my final answer. Okay, number 6. I kind of ran out of running out of room for factoring over here, but first thing I'm going to do in the numerator is divide by a GCF. So I'm going to take that 3a out. Same thing in the denominator. I'm going to divide by a GCF first. Both can be divided by 6a squared. So I get that out first. Next thing in the numerator, 4a squared minus 1 is a difference of squares. I can factor that into 2a plus 1, and that's supposed to say 2a minus 1, but it's kind of going off the page there. So then what we have, 2a plus 1 is a common factor. I'm going to cancel those both out. And then I should be able to cancel a with a squared. And then here I should also be able to have 1 and then over 2 for 3 over 6. So that leaves me with 2a minus 1 all over 2. All right, so that's this page and some examples. If you want more examples, they are on the video notes complete. Next page, we're going to talk about multiplying. Okay, so if it's just monomials, meaning like what you see in number 9, then we can multiply them all together and then simplify. I also like to do cross-simplifying. So if you see common factors in numerator and denominator anywhere across the numerator and denominator for multiplying, then you could cancel them out. So I'm going to show you actually probably another way to do number 9 here in a minute. Okay. All right, so number 9, it's a monomial. I just multiplied across and then simplified. The other thing I could do, though, is I can see that 6 and 18 are common factors, so I can make that a 1, and I can make this a 3. And then 10 and 2 have common factors of a 2, so I can make this a 1, and I can make this a 5. So that automatically is going to get me 5/3 right away. I could do things like this as well. X squared and x squared are common factors. And then it would be really easy for me to simplify and have 5/3, and then I'd have x cubed, and then I'd have y to the 7th over y to the 4th, which gives me y cubed. So you can do cross simplifying as well, if that makes sense to you. If you're like, what the heck just happened? Don't worry about it. Okay? You can just multiply all the way across and then simplify at the end. It just means you might be working with some bigger numbers. So if you can recognize common factors on top and bottom, you can start simplifying. Okay. Number 10 should be pretty similar as well, so you can check that on the completed notes. Number 11. We are no longer working with just monomials. Monomial, remember, means one term. So now I have a binomial, and then a trinomial, and a trinomial, and a binomial. So if I'm doing that, I have to be really careful here. First, we want to factor everything, and then we'll simplify from there. So I factor in the numerator of the first one by taking out a GCF. Then I'm going to factor the numerator of the second one. I'm looking for factors of -6 that add to give me 1. So I got -2 and 3. I know that's kind of hard to see. That says x plus 3. And then I'm going to factor in the denominator. So first thing I pull out is a 2, and then I'm looking for factors of -3 that add to give me 2. Okay, so I have 3 and -1. Then with the second denominator, I'm factoring out a common factor, which is 4x, and whatever's left. Okay, and then I want to start looking for common factors. So I see 4x and 4x. I see x minus 1 and x minus 1, x plus 3 and x plus 3. So I can cancel out all those common factors, and I'm left with x minus 2 over 2 times x plus 2. Okay, so that's my final answer, multiplying and simplifying. Okay, so factor first, then cross cancel. All right, so to divide rational expressions, it pretty much is the same thing as multiplying. The only thing we need to do is make sure we change it into a multiplication problem with multiplying by the reciprocal, just like with fractions. If we were going to take a fraction divided by a fraction, instead we're going to do the first fraction multiplied by the reciprocal of the second. So that is all that I did here with number 13. I left the first fraction the same, and then I said times, and then we do the reciprocal of the original. So I have 8 q to the 5th over 35p squared q squared. Okay. Then same thing as up above. You can multiply all the way across with the binomials and then simplify. Or if you recognize like 5 and 35, I could cancel 5s there. So I could have a 1 and a 7 here. I could have a 1 here and a 2 here. So it just might make your life easier simplifying that way, but it doesn't really matter. Okay, now we're going to move down a little bit to number 15. So again, I'm going to factor everything. So I factored the numerator and denominator of my first rational expression. Go ahead and check and make sure that makes sense to you. I did GCF and then factors of -12 that add to give you -4. And then what I decided to do is multiply by the reciprocal. So I took, oh, did I take it? Let's see. Okay, so I took out a GCF in the numerator, but I didn't change this out of a division problem, guys. So I need to fix this. So this should still be divide, right? Okay, because I'm dividing here, and I need to multiply by the reciprocal. So, let's see. I'm going to have to erase my answer. because what we really need to change this into is another problem. So I'm going to pause it and see if you can change it as well, and then we'll come back to you. Okay, let's check and make sure that we agree here on this setup. So I left the first one the same, and then we multiply by the reciprocal. Okay, so now our setup should look good. This is an a minus 6, and so is this, so we know that those should cancel. I have an a squared here and an a squared here, so I know that those should cancel. I have an a minus 3 and a 3 minus a, so those should cancel out and give me, remember, a negative 1. So I'm going to go ahead and cancel those out. Okay, I still have 2 in the numerator and a minus 5. I have a plus 2 and then 8. 8 and 2 can both be simplified as well, so my final answer should be a minus 5 all over 4 times a plus 2. And leaving it in factored form is totally okay, because if we had to do some sort of problem like this and then graph it in the future, we would want it in factored form to be able to find all the asymptotes and intercepts that we could. Okay, so hopefully that makes sense so far. And then adding and subtracting. Okay, so we've got adding and subtracting rational expressions. We want a common denominator. Remember, we combine the numerators just like with fractions, and we keep the common denominator. So here's an example of a number 1. Already have a common denominator, so I'm going to add straight across in the numerator and get 18a, keep the denominator for a squared, and then we simplify. So an a can cancel out a squared. 18 divided by 4 simplifies to 9 over 2. Okay, same thing with number 2. You can check that. I'm sure you can go through these and see the rest of them as well. Unlike base examples, okay, so I want to look for a common denominator. So here, common denominator would be 6x, because I have 2x and 3x. I'm going to multiply the first one by 3, multiply the second one by 2, and then it becomes just like the other problems. Okay, complex fractions. So complex fractions is like ultimately dividing fractions again. So I'm just going to rewrite it as the first fraction divided by the second and change it into a multiplication problem. So they look super funky, but it's the same thing as what we were doing up above. So this becomes a over 2 times 4 over a squared, and then we simplify. Number 4, write the first one times by the reciprocal of the second one, and then simplify. Okay, same thing for number 6. Write the first one times by the reciprocal of the second one, simplify. Okay, so all those should be the same. Again, if you have any questions, let me know. I think that's the end of these notes. And then you should have an assignment on reviewing operations of rational functions.